thank you all for being here today. I truly appreciate the fact that you're taking time out of your schedules. I know that's really tough for everybody to do. So thank you for being here. My name is Becky Anderson. I'm a hazmat chemist, former volunteer firefighter EMT, and have worked in the hazardous waste, solid waste industry for more than, oh gosh, a really long time now, 25 years. And I've been helping schools for about the last 20 with management of hazardous chemicals and how to operate safely. We know schools have a lot of chemicals in a lot of different areas. So not only do we want to meet the regulatory compliance requirements, but we also want to make sure that we're doing things as safely as possible. So before we get started, I want to say thank you to Vicki Davis out at Upper Valley Lake Sunapee Regional Planning Commission. Vicki is the mastermind behind the USDA grant writing that achieved funding for us to be able to offer these to you. They will be recorded and you'll be able to access them later on. So if you want to really get into the nitty gritty and stop and listen a slide at a time, you'll be welcome to do that. And again, there's no charge for any of that. Also, just a quick shout out to my friend Dave Waddell. We lost him about a year and a half ago, but he was my mentor in this. And you'll see a lot of photos from Dave Waddell in various presentations. So he was generous enough to pass those along to me, and I truly appreciate it. Goals for this month, ultimately, our goal always for these webinars is to make sure that you're operating with chemicals as safely as possible. We know that's tough to do in schools, and so we're going to give you some guidance and some help on the regulatory side of things. This series of webinars is really focused on regulatory compliance. So it's tough. We're going to do a quick review of the OSHA requirements that we talked about last week, and then we'll get into more of the EPA, Department of Environmental Services, Department of Environmental Safety aspects today. So today we'll be focused a lot on waste disposal. One of the resources that I'd like to point out to you is Lab Safety Institute. I've been familiarizing myself with their website, and they do offer some exceptional options for additional training, courses, resources. They're just a really, really neat institute. And they have a lot of free resources in addition to a very reasonably priced membership. So I'd take a look at that if I were you. They are quickly becoming one of my go-to resources. And then we are going to spend time in the next few months on helping you to build your chemical hygiene. And I call it the chemical hygiene lab safety plan. Chemical hygiene plan gets a little confusing for schools. So I always throw in lab safety. It just kind of clarifies things a little bit more. And ultimately, what we're focusing on is a chemical life cycle. So, and that's what I really want you to think about today. So we've talked about procurement and how we want to build in some standard operating procedures to make sure that we're managing purchases. We've talked about use and storage. We spent quite a bit of time on storage last week. We'll spend a little bit more in the upcoming weeks. Next week we are conducting a webinar on use and how to select and evaluate risk for the chemicals that you have on site throughout the district. Today's focus is on disposal, but ultimately what we want you to think about is that life cycle of when you bring a chemical into the school district, how are you going to use it safely? How are you going to store it? Do you have all the right safety precautions in place? And then ultimately, how are you going to dispose of that? That's been one of the pieces that's really been missing for the last 60, 70, 80 years in schools throughout the United States. We have got to really focus on ending this legacy chemical problem once and for all. We start with a procurement policy and we end that with a disposal policy. And hopefully that will allow us to not have to deal with this in another 10 years. Tips for Zoom controls, we will have the chat off today until we get about 5 minutes from the end. Then we'll open it up. And if you have any questions, you're welcome to type them into the chat and we'll see if we can get them answered for you. Okay. Now we're going to start off here with a quick review of last week. And I will let you know I have a lot of material to cover today. So we will probably go right up to 10:30. bear with me. There's going to be some of these slides that I'm going to talk through really fast because we've got so much material to cover. Unfortunately, hazardous waste disposal is a really, really tough topic. It's very complex. So we're going to do the best we can in a short amount of time to help you to understand what you really need to know. Last week, we talked about understanding chemical safety roles in the district and how we really need a systemic approach to all of this legacy chemical and safe chemical management in schools. It can't come from individual departments necessarily. It can't come from individual schools. Really needs to be approached from the district level, and we need a systems process to evaluate how we handle these things. We talked about the OSHA laboratory standard. We talked about how states have different rules than each other. There are ultimately what we see is that there are federal rules for safety and for chemical management that are established by the federal government. And then what typically happens is the state governments become authorized to enforce those rules and to help assist generators or assist participants in using those rules. The state rules have to be as stringent as the federal rules, and they can be more stringent. So in OSHA requirements, we do see more stringent requirements than just the federal OSHA requirements in a lot of states. So the key message there is to understand what the rules are and who has jurisdictional authority in your state. We talked about the role of the chemical hygiene officer. And the chemical hygiene officer is really a conduit between that district system approach and the individual schools, as well as the departments within the schools. So your chemical safety officer, which is a required establishment, you have to identify a chemical safety officer according to OSHA regulations. And that chemical safety officer really needs to have exceptional communication skills. They need to be able to work at the district level as well as individual classroom levels. So you want that person to have a really good ability to communicate and discuss things. It's helpful if they have a science background, but it's not a necessity. There are resources to help them kind of ferret through all of the different individual concerns with different chemical classes. So it's not a necessity. And typically what we see is that the chemical hygiene officer usually works in the facilities area because they are in all areas of the school and touching all parts of the school. We also talked about the building blocks to prevent legacy chemicals. And as I mentioned before, the very first thing we want to start with, or one of the things we want to start with, is a really solid procurement policy. So how do we know what's coming into schools? Who's evaluating how risky those chemicals are that are coming into schools? We talked about having a safety committee, a chemical safety committee. That can be the same as the safety committee at the district. It can be the same group of people. And then to just have a subset aside from that of chemical safety orientation, that would be really, really beneficial and really helpful. The most successful districts that I've seen kind of have that structure. They have a district-wide safety committee, and then a subset of that, that's the chemical hygiene officer and a couple of key players, curriculum, purchasing, and then representatives from art, science, and career technical education skills. So that would be things like the woodworking shop and the automotive shop. So we also talked about inventorying chemicals and identification of legacy chemicals. And we talked about some practices to help you a shelf at a time with an inventory of the chemicals that you want to keep, as well as the chemicals that are in need of disposal. And right now we're going to just refer to those as excess chemicals for evaluation. We're not going to call them chemical waste at this point. I'll explain that a little more as we go through today. Today we're talking about how we're going to do a quick review of the lab safety standard, and then we've had a lot of questions about how that dovetails with the hazard communication standard. So I'm going to give you just a quick overview of those two sections, and then we're going to jump right into the complicated land of waste. We're going to talk about who regulates hazardous waste management and disposal. We're going to talk about how states are a little different And we're going to talk about what is hazardous waste. We're going to introduce you to some of the language that is very unique to waste management when it comes to EPA regulations. And then I'm going to hopefully talk with you about 12 steps that we can move through hazardous waste disposal, and then build ongoing sustainable programs. So again, we don't have this buildup of legacy chemicals. So lots of material to discuss today. I'm going to start with that quick demonstration of competency and a quick sip of coffee before we jump in. So, true or false? These are things that you may not know the answers to right now, but hopefully by the end of the webinar today, you will know the answers to these. True or false? Flammable solvents can be dumped down the drain if you flush them with lots of water. Is that true or false? True or false? Art departments don't have hazardous chemicals that are regulated. And then true or false? School districts are exempt from hazardous waste regulations because they are government facilities. So jot down a note, are those true or are those false? And then we'll address those at the very end today. Okay, quick overview of the OSHA lab standard. And I gave you the code citation that you can find and read this in. 29 CFR stands for Code of Federal Regulations, 1910.1450. And I'm actually going to refer to this as the 1450 standard, okay? 1450 is the lab standard. And one of the things I wanted to emphasize to you was, okay, just because it says lab in the code, the OSHA definition actually expands that based on 3 different criteria. So in order for something to be a lab in a school district, it's not just a science lab, but if it's an area of the school that's working with small quantity, for example, laboratory scale use of chemicals, and they have a wide variety of chemicals, and it's not used in a production process. If the area of the school meets all 3 of those criteria, it can be defined as a lab under OSHA, and it needs to be part of your chemical hygiene lab safety plan. The OSHA lab standard does apply to it. So I want you to think about art studios. They use small quantities of chemicals. They've got a wide variety of chemicals, and they're not in production. Theater shops. When we say production process, that's a manufacturing production process, not production as in I put on a school play type thing. Okay, so this standard can apply to art studios, theater shops, woodworking areas, automotive, greenhouse, horticulture, facilities, kind of, depending on the quantity of chemicals and the use of chemicals. But what I want you to understand here is that that opens up several areas of the district, several different areas of a school that would be subject to the OSHA lab standard. So please keep in mind that this is not just targeted at science labs. The components that are required by the OSHA lab standard include a written chemical hygiene lab safety plan. There are 8 parts of that, and we will be going over that in the next few months. That lab standard also requires things like information and training. Where is the lab standard written plan kept? Exposure symptoms, understanding limits of exposure, safety data sheet information, protective measures, so engineering controls or personal protective equipment, training, emergency procedures, labeling, record keeping, and medical monitoring if there is an exposure. So as you can see, there are a lot of different components addressed by the lab standard. It's really important if you're going to serve on the district safety committee or the chemical safety committee subcommittee that you understand this. So I would encourage you to go and pull that section of code up and read it. It is code. It's very difficult to read. The more you go through it, though, the more I think you'll glean understanding and know what you need to do. And then it also defines the chemical hygiene officer's role and what criteria are needed for someone to be a chemical hygiene officer. One of the things that Lab Safety Institute has are some courses for chemical hygiene officers, how to be the best chemical hygiene officer possible. So I'd encourage you to take a look at those. Key message of the lab standard is to make sure that you have that chemical hygiene lab safety plan written and that you've addressed all of these different topics. That's one of the key pieces. Building that district chemical safety team, again, you can have a subcommittee that's of the district safety committee if you'd like. It doesn't have to be two separate groups. In fact, I would encourage you to make sure that those groups are integrated together. At the district level, we're going to focus more on policy and on systems. So how are we going to make sure that that infrastructure is in place from procurement, from the curriculum perspective, from what's required for teachers to do and use in their day-to-day operations of teaching students. And then we're going to button everything up with those policies and procedures on how we dispose of things in an ongoing measure. The building safety committee is more about day-to-day procedures. So those standard operating procedures that you're using in your class to make sure that everything from ceramic glazes are handled safely and the kiln is vented to I'm managing my acids separately from my bases and not putting them in the same corrosives cabinet. So those are the types of things that we would address on a building by building basis. And I've given you kind of a breakdown of who representatives that should be present in that chemical safety committee at the district level and then also at the school level. The chemical hygiene officer, again, that role is really critical. That chemical hygiene officer role has to span both of those, the district systems level of things, as well as the building and the department day-to-day operation of things. It's a big job. And it does require some chemical knowledge, but just to emphasize again, it does not have to be someone from your science department. The key to a really good chemical hygiene officer is understanding what they need to do. So training and education, understanding, and then communication. Communication is absolutely critical. Okay, we've had a lot of questions that have come in about, okay, what do I need to keep a safety data sheet for? So I want to address that specifically just real quick today. I'm going to talk with you about another OSHA program. So we have the OSHA lab standard, which is the 29 CFR 1910 1450 plan. And then a different section of OSHA actually addresses safety data sheets and management of safety data sheets. And that's the hazard communication program. That's in 29 CFR 1910.1200. Excuse me. So this is the 1200 section. We previously talked about the 1450. In the 1200, areas of impact in the school are areas where chemicals are used. And this 1200 section was actually in place before the lab standard. So OSHA decided, you know what, we want to take a look at how chemicals are being used to make sure that people are knowledgeable about how to protect themselves from any health impacts of chemicals. And associated with that then was the development of the hazard communication plan, which essentially is designed to communicate the hazards of chemicals to all employees using those chemicals. OSHA decided a few years later that, wow, lab chemicals are kind of unique because they're small quantities, but they're usually really concentrated and they can be more dangerous. And so at that point, OSHA developed and implemented the OSHA lab standard. Okay, so two different programs here. Hazard communication designed specifically to convey risk to employees. It is required to have a written plan of how you're going to convey that information. And then it's additional details as far as the things like safety data sheet management, labeling, information and training that are required as a part of this, OSHA pictograms, and inventory management. So those are the key parts of the hazard communication plan. The areas that the hazard communication plan was initially targeted at was all chemical areas of the school, but with specific emphasis on facilities and non-labs. So if we look at it in detail, the lab standard is the authority and the regulation that you need to fall under if you are a part of a lab, science lab, art lab, woodworking shop, any of those things. If you are not part of the lab standard, so you don't meet that definition, but you still have chemicals in your area, then you fall under the 1200. So they are, kind of two sides of the same coin. The biggest thing is both of them have to have written plans. And we have to have a good understanding of what we need to do to meet the requirements of the hazard communication plan. So specific requirements, we've got to have that written plan with training for employees. And I'm going to say a demonstration of competency, a quiz. That's it. It's not a requirement of the code, but it's certainly encouraged by OSHA and all of the state agencies that enforce the hazard communication plan. Safety data sheet management, labels, and secondary container labeling. We're not going to spend a whole lot of time talking about that today, but you need to understand that the days are long gone of being able to take a piece of lab tape or duct tape and put it on a secondary container and just write the name of the chemical. We can't do that. We have to meet the hazard communication requirements for labeling. So make sure that you're familiar with those. And then education on risk assessment. How do you evaluate whether or not a chemical is too risky for you to be using on site or in a lab? And we'll talk about safety data sheets more next webinar. Key focus, make sure that you do have a written hazard communication plan. That can be at the district level, but then there needs to be initial or amendments or addendums that address the operations of each individual school or department. Sorry, I didn't communicate that very well. We've got to have that written policy up at the district level, and then we roll down individual operations to schools and departments directly. Now, safety data sheets, which are a part of hazard communication, they're also a little subsection of the lab standard. So regardless of where you are in the school, if you are using chemicals, you are required to have a safety data sheet that addresses the risks associated with those chemicals. It also addresses things like safe storage, personal protective equipment, exposure limits. So all of those things are really critically important. Before we get into the requirements of when you have to have a safety data sheet, I want to emphasize to you that I'd like to encourage you to think of this as a best practice. So do you have to have a safety data sheet for everything? No, there are some exclusions. We'll talk about those in just a few minutes. However, when you think about it from a best practice and a safety perspective, would it be helpful to you in the event that you have a student or an employee that is exposed to a chemical through a spill or through some crazy thing? Wouldn't it be helpful to you to know what the specific risks are of that chemical? And wouldn't that be good information if we need to pass it along to an emergency responder or to an emergency room doctor? Wouldn't it be beneficial to have that? So those are things I want you to keep in mind. It is perfectly acceptable for you to keep extra safety data sheets on site. Absolutely acceptable for you to do that. The key is you want to make sure that you do have all of the required safety data sheets. Now, this list for you identifies chemicals that you do not have to have safety data sheets for. Again, if it's a best practice, if you think it would be valuable, get one anyway. All right, hazardous waste doesn't have to have safety data sheets. Thank goodness, because a lot of our hazardous waste gets really convoluted on ingredients. So not necessary to have hazardous waste safety data sheet, or this says hazardous substance, which is the focus of remedial removal action. If you have something like contaminated soil or something, which hopefully you don't have at your district, but that would be something you don't have to have a safety data sheet for. Now, this is where it gets more applicable to school districts. For tobacco products, you do not have to have a safety data sheet. Wood or wood products. So if you've got a hunk of oak and a hunk of maple in the woodworking shop, don't need to have safety data sheets for those. Food or alcoholic beverage, I'm not really going to talk about the alcoholic beverages part. I think there's probably other school policies that address that, but food. You do not have to have safety data sheets for food, especially if they're intended for personal consumption by employees. Any drug, so think medications in the nurse's office, you do not have to have safety data sheets for those. Or if you keep a bottle of Tylenol in your purse, something like that, you don't have to have a safety data sheet for that if those are on site. Cosmetics are not required to have safety data sheets. And then this is the really critical one, and I want you to really think about this one. When a chemical is used like a consumer, you don't have to have a safety data sheet for it. If it's used more frequently, more intensely, then you do have to have a safety data sheet. So key questions that have come in, things like rubbing alcohol. I can buy them at any of my local grocery or box stores, okay? If I buy it and I only use it occasionally like a consumer, and it's a consumer quantity product, I don't have to have a safety data sheet for it. Things like I get questions about, well, we had somebody tell us we have to have a safety data sheet for dry erase markers. No, however, okay, just something to think about. If we have a student that has taken a bunch of safety data or taken a bunch of markers and has been inhaling them or doing ridiculous things with them that are dangerous, wouldn't it be helpful to have that safety data sheet to give to an emergency responder? Not required, because that's a consumer-like product and you're only using it like a consumer would. So you have to kind of ask yourself as you're building your safety data sheet, is this something that I could get as a consumer, and am I going to only use it as a consumer would? If that's the case, no safety data sheet is required. However, when you're using it on site at a school with the number of people that could mess with it, might be helpful for you to have that safety data sheet. Okay, that's a tough concept. If you have additional questions, please type them into the chat at the end and I'll see how many I can get through. All right. Okay, now we're going to change gears. We are going to start talking about waste. So we've covered the lab standard, the 1450. We've talked real briefly about the hazard communication standard, the 1200 section of code. We've refreshed on what a chemical hygiene officer does and how chemical management really needs to be set up for the life cycle of the entire chemical, so from procurement to disposal. So now we're going to really dig into that last piece, disposal. Before we get started on this, I want to tell you that I'm going to go through these regulations and I'm going to tell you some things that are going to be really difficult to understand and they're going to be really confusing. I want you to know our hazardous waste regulations are tough. They're among the toughest types of regulations that we see in the United States. So bear with me as we go through this stuff. I'm going to try to make it as simple as possible, but there are just some of these regulations that honestly don't make a lot of sense. But we still have to do them. So we're going to try to get through it as easily as possible. We're going to talk at the district level. This is a systems approach to hazardous waste management. That becomes critical, and I'll explain that to you as we get further into understanding those regulations. But really, we need to have a system in place that the entire district, that every school, and that each department can follow when it comes to waste management. We want to build these systems so that they are sustainable, so that we can once and for all eliminate this legacy chemical cleanup. Now, all of these regulations are written at the federal level and they're enforced by the Environmental Protection Agency. We call these the RCRA, or Resource Conservation and Recovery Act. We've referred to it, the slang term is RCRA. It addresses and oversees management of solid waste, recycling, hazardous waste, and a category of waste called universal waste that we'll touch on real briefly. Just like with OSHA programs, it is administered first at the federal level, and then states are authorized, if they choose, to also administer and enforce at the state level. At the state level, those regulations have to be as stringent as they are at the federal level, but states can add on additional requirements. They can be more stringent. And most states do this. New Hampshire and Vermont in particular are two examples of states that they have the federal regulations as a base, and then they add additional state regulations. The only state that does not enforce its own RCRA regulations, and they rely on the federal government to do that, is Iowa. Alaska to a point, but Alaska does have some state requirements. All right, RCRA, Resource Conservation Recovery Act, has been around for a long time. And we've gone through iterations or improvements to, the latest one was in 2016, improvements to the generator improvement rules. This is the way that this legislation or the way that these laws are set up are that the person that is creating, the person or entity that is creating the hazardous waste is called the generator. It's the language that EPA uses to refer to the person or entity creating the hazardous waste or the waste. And that generator then is responsible from cradle to grave for management. So the entire life cycle of that chemical, that generator is responsible for. The penalties from EPA or from State Department environmental enforcement agencies can be substantial. So this is and in Iowa in particular, we tend to see more enforcement dollars go out to EPA than even to OSHA. So this can be really substantial. This is information that we need to make sure that we're not messing up. Overall, the goal is to protect human health and the environment. Secondary goals to conserve resources and to make sure that we have recycling and recovery of resources as much as possible. As I said previously, Vermont and New Hampshire both have state programs, and both of them are more rigorous than the federal program. All right, this is where things start to get interesting. So these are all different types of waste that EPA defines. And the states also administer regulations addressing, and we've made it super complex. In New Hampshire, the state regulatory agency overseeing these hazardous waste regulations is the Department of Environmental Services. If you're in New Hampshire, I would encourage you to go out to their website. They've got a lot of really good resources. They're also very happy to help if you call in and ask specific questions. Very, very good resources on the website. They have more stringent requirements than the federal government does, and new in 2026, they now use the same generator categories. We will talk about that in just a few minutes, but generator categories are critical for you to understand. One of the things that's a little unique to New Hampshire is that they do require a designated hazardous waste coordinator. And they also require every generator to register and get an identification number with the state. So please make sure that you're paying attention to that. New Hampshire also has specific waste codes. All right, switching over to Vermont. Vermont's hazardous waste program is overseen by the Department of Conservation. They also have exceptional resources. If you are in Vermont and you're trying to figure out all this hazardous waste, solid waste, recycling mess, take a look at their website. Really good resources for you. They also have stringent requirements. They have the same generator categories or generator classes as the federal government. They also require all hazardous waste generators to register with the state, and they also have specific waste codes at the state level. So again, similar themes with both of those states, with both New Hampshire and Vermont. You've got to have an identification number. You've got to make sure that you understand state waste codes and understand that they're more rigorous than the federal codes. So waste generation, now we're going to start getting into some of the language that EPA uses. Cradle to grave means that when you decide something is waste, that becomes what's called the point of generation. That's when all of a sudden that moves from that particular chemical or ingredient moves from product into waste. And as soon as we cross that threshold, we move and we create what's called the point of generation. Once you generate something, decide that you don't want it anymore, and you generate waste, it becomes your responsibility to manage it properly and in compliance with all the regulations. You have to dispose of hazardous waste at a permitted treatment, storage, disposal facility. We refer to those as TSDFs. You want to make absolutely certain that your hazardous waste is going to a permitted TSDF. And one of the things that we have that EPA spends a lot of time on in particular is defining what is a waste. A waste is something, if you don't want it, if you can no longer use it, if you don't know what it is, if it's been orphaned or abandoned, or if it's a spill that is not recoverable as a product. All of those criteria meet the definition of different types of waste. As the generator, again, you make the determination of when the point of generation is. It's very critical that you understand that. So for example, if I'm in my woodworking shop and I've got 30 cans of different colors of stain, and they're all kind of partially full, and I get to the end of the school year and I go, you know what? Next year, I'm going to make this a little easier. I'm going to give a little less choice on color of stain. And I'm going to identify, I'm going to keep the 10 most popular, but then I'm going to identify 20 of them that I can get rid of, I can dispose of. Stains are typically flammable. So they meet the definition of hazardous. And as we're going through those 30 cans and we're picking out the 20 that we want to get rid of, it is critical that we understand that as soon as we move them from product to waste, and we decide that we no longer need them, we move them from product to waste, that's the point of generation. The reason that is critical for two factors. One is your generator status, and we'll get to this in a few minutes, is dependent upon how much waste you generate in one calendar month. So if all of a sudden you generate a lot of hazardous waste, you're more regulated. In addition to that, as soon as you generate hazardous waste, you've now set off a little clock for EPA or for the state agencies that says, you know what, I have a certain amount of time to get rid of this now. So one of the things that one of the strategies that we have in industry is we make certain that something is a waste before we generate it as a waste. If we're still thinking about chemicals and we're thinking about, is there someplace else or somebody else that can use this? We can identify that as excess chemical. It sounds like it's just a difference in the wording, but it's a substantial difference under regulations. If we move something into a pile that says, or an area that says, you know what, I'm going to continue to evaluate this and see, is there someplace I can rehome this? Then it's not a waste. You haven't achieved that point of generation. Okay, these are critical things that we need to talk about and understand as we're moving forward. All right, this is in the EPA guidance on easy to understand regulations. I'm going to tell you, this is like the furthest thing from easy. It's kind of a mess. So we're going to simplify it. All right. I'm really trying hard not to make your heads explode. So we're going to go through what you really need to know about hazardous waste. We're going to start by regulation by site and understanding what that means. So EPA doesn't regulate by department. They don't say, okay, the science lab can get rid of 200 pounds of chemical every month. The art lab can get rid of 200 pounds. Facilities can get rid of 200 pounds. They don't do it that way. EPA defines a site as a facility that has chemicals and is not split by a DOT authorized recognized roadway. So if you happen to be in a school that is attached to a bus barn and there's no road in between them, that entire site is regulated as one generator. Really critical for you to understand this. This is why we have to have a system approach. Regulations are based on how much the quantity in pounds or kilograms of hazardous waste is generated in a calendar month. More generation means more regulations you have to fall under. So we want to keep those as minimal as we possibly can. The collection areas, so where we collect hazardous waste on an ongoing basis, we have two different types. One is called the central accumulation area, and that's where we store hazardous waste. When we've designated it, we've created a point of generation, it's been designated as hazardous waste, and we're waiting for a hazardous waste company to come pick it up. That's the central accumulation area. And we have a number of rules that we have to follow for that central accumulation area. The other are small areas, small locations where we collect waste in an ongoing manner. Those containers are called satellite accumulation containers. And they're basically things like in the science lab, if we're using acetone to rinse and dry glassware. Every time we generate a little bit of acetone, we pour it into a waste collection container. That's a satellite accumulation container. We'll talk about the rules for both of those. Ultimately, this is really complex, but we want to build long-term strategies to make sure that you are understanding what is required and that you can implement those things to avoid all of this large legacy chemical buildup that we seem to be finding about every 10 years. EPA does have a language all of its own on this, so bear with me on it. This is the system approach that we're going to be taking. So we want to work at this high level, and we're going to follow these 12 steps to build in a sustainable plan for you. We've already started by identifying, we started with legacy chemical and chemical evaluation in sciences. We didn't really talk about that in career and technical education, things like woodworking, things like automotive shop or in the art department or in the theater department, but you can use the same principles. So please go back and take a look at how we identified legacy chemicals and then how we began to inventory them. So that's where we are in the process. By the end of today, we're going to get through all 12 of these. I know it's going to be crazy. Okay, where are we at? We've inventoried and we've identified excess chemicals that we need to get rid of. All right. One of the things that you need to identify or to know is that as soon as, again, you determine that it is a waste and you want to get rid of it, that starts the clock on how long you have before you have to get rid of it. It also adds to the quantity at your site of how much waste is generated. And if we don't control that carefully, we can move into what's called a large quantity generator status very easily. And then we are required to comply with every EPA regulation regarding hazardous waste and state regulation that's in place, which is a lot. So more hazardous waste on site also means more potential for fine. Let me help you understand sites a little bit more. So all these environmental regulations regulate based on the site of generation. Site of generation is the entire facility where hazardous chemicals are being identified and generated. And if it's just a single, if you're just in a K-12 building or a K-6 building, that alone can be one generator site. Keep in mind that within that site, we could have an art room, a theater, a couple of science labs, a couple of automotive labs, a couple of woodworking labs. All of those have to work together as a site to manage hazardous waste. If we also tack on 2 or 3 additional buildings on the site, like we have a greenhouse, we have a bus barn, all of those buildings meet the definition of the site. It's called a contiguous site under EPA regulations, as long as there's not a DOT roadway through. That's why it's really important for us to manage this at the site level, at the district level, build in a system. Every time we identify a site, we have to obtain an identification number. All right. Even if those buildings are attached to each other, but we have like two different shipping addresses, that doesn't matter. If those buildings are on the same site and there's no DOT roadway splitting them, they are one contiguous site according to EPA or a lot of the state regulations. First thing we want to start with, especially when we start managing hazardous waste, chances are the first cleanups you're going to do are going to be big ones. There's a lot of opportunity I see for stockpiling and buildup because we just haven't had these systems in place. So you need to identify which approach is better for your district. Is it better for you to start looking a little bit at a time in different areas throughout the school, identifying excess chemicals, and then determining, you know what, we're going to go ahead and get rid of these this month, this calendar month. And if we do that at using a certain limit on the poundage that we've generated, we can manage that, but it has to be coordinated at the site level and it has to be really closely managed. A lot of schools will save up money and identify that, you know what, we're going to do one clean out, one big clean out. And then we're going to build in sustainable programs. Either approach is fine. Just understand that if you build up a lot of hazardous waste in one calendar month, you're going to fall under more stringent regulations and rules. Can you hire a company to just come in, take care of it all? Yes, you can do that. There are a lot of companies out there that will come in and they will inventory the waste for you. And I've seen some that do an absolutely outstanding job. Maine Lab Pack is one for those of you in Vermont and New Hampshire. Maine Lab Pack has been one of the partners and resources that we've used over the years. They do an exceptionally good job. We do have a lot of other hazardous waste companies. You'll want to research those and make sure that they don't have a lot of violations, that they've not done things incorrectly. And you also want to have a safety net person that evaluates what they're going to dispose of for inventory. I have over the years seen schools pay a lot of money for disposal of non-hazardous items that could have been put in the trash. So it's a balancing act. When I say a lot of money for a mass cleanup throughout a particular site, the costs have certainly skyrocketed in the last few years. Most chemical cleanups that I see are less than $20,000. So I don't want you to think that that we're talking, a $500,000 to clean stuff up. That is not the case. Most of them are under, unless you've been stockpiling for a really long time and you have a really, really large inventory. I would say that probably $20,000 or less is what I typically see. Again, that's a big number for a science department, a big number for an art department. And I know your eyes just about fell out of your head when I said that. Keep in mind, though, that if there's planning at the facilities level, there may be funding to get that done at the facilities level. So it's really, you have to determine which approach you want to take. Do you want to do it a little bit at a time, every month, dispose of things? Or do you want to just have a company come in and get rid of all of it at one time? And it really is a budget question. Do you have a household hazardous waste facility option? We're going to talk more about this, but if your state has household hazardous waste facilities that are permanent facilities, or if they offer annual household hazardous waste cleanup days, they may authorize you or enable you, if you are a very small quantity generator, to bring in waste to those facilities or bring those into those household hazardous waste cleanup days. But it's only for the least category of hazardous waste generation, and that's very small quantity generators. We'll talk about what that means in the next few slides. If we can use an HHW facility, we save on disposal costs because usually that pricing is negotiated. We also save on transportation costs. There are times that we can transport it to the HHW facility or one-day event by ourselves, and we'll help you do that safely, so will they. So there's a lot of savings potential. Plus, if you can maintain your site as a very small quantity generator and you're in a state where VSQGs are allowed to dispose of things at HHW facilities, there you have some excellent, good, sustainable options for ongoing management of the disposal of these chemicals. So it's really a super awesome thing when we have schools that can work with HHW facilities in an ongoing, metered manner to generate and dispose of their hazardous waste every month as it's generated. Minimizes risk. It's just really a good option. So remember, as we're starting, first we're inventorying our chemicals and we're identifying excess chemicals that we want to evaluate. Is there somebody else in the district that needs them? Do I have an overabundance of some chemical that a high school that's in my district is getting ready to order and I've got extra that's in good shape? You know, are there things that we can do to transfer those chemicals, to use those chemicals so that they don't become waste? They're at this point, while we're evaluating that, they're excess chemicals under evaluation. They are not regulated by waste until we make the determination. Once we make the determination that they are waste, then the quantity limits kick in, and also the timeline for how long you have to get rid of those chemicals kicks in. We have professional assistants that can help you with this, either through hazardous waste disposal companies. My company is available to help you with this. We've also got Lab Safety Institute that's helpful and offers you resources for this. So we're on the second tier now of where we've established that we've identified our site. We've obtained our identification number. We've decided, do we want to do this as a one and done big clean out and then build in sustainable practices? And we've got a list of our excess chemicals that are under evaluation. The next thing that we want to do is what's called a waste determination. So those excess chemicals, we need to evaluate them to determine, are they in excess? We don't have any use for them. And then if they are in excess and we're going to dispose of them, they move into the waste category. And then we have to make what's called a hazardous waste determination. And we have to ask questions about the type of waste this is. Is it hazardous or not? Okay, this is EPA, more EPA language. This is one of the aspects that I would encourage you to have as a standard operating procedure, the instructions on how to determine if an excess chemical is a waste, and then if that waste is a hazardous waste. We want to include that in your chemical hygiene lab safety plan so that we have an SOP so everybody operates the same way at the district level throughout the district. We want to make sure that we're understanding what hazardous waste is. Now, does this all have to be done at one time? No. Again, this is up to you as the generator. You can decide 220 pounds at a time if what you have is hazardous waste and needs to be disposed of. And the reason I keep throwing out 220 pounds is that's the threshold limit for a very small quantity generator to dispose of in a calendar month. The generator is the authority and decides that process. Now, EPA does have a designation of what's called inherently waste-like. So if we have, and typically this is focused more on industry, but if we have an industry that sets a whole bunch of excess chemicals in a room and then abandons them, leaves them, and ignores them for 2 years, 5 years, 10 years, however, EPA can come in and say, you know what, EPA or the state agency can come in and say, you know what, that's inherently waste-like and you just haven't managed it. So that's the safety net that says we can't just continue to ignore these things. We do have to identify anything that is a waste, but we can do a lot of it in our own time and in our own quantity. And we can limit that to 220 pounds a month. As the generator, it's our decision. If there is an HHW facility, I would encourage you to reach out to them and ask them if they accept VSQG, very small quantity generator waste. If you're generating less than 220 pounds in 1 calendar month, you very well may likely be able to use that HHW facility. States that clearly allow VSQG disposal at HHW facilities: California, Connecticut, Indiana, Maine, Vermont, New York, Minnesota, Washington, and Tennessee. We do have some states that say absolutely not. Alabama, Mississippi, Louisiana, Kentucky, South Dakota, Wyoming, Arizona, it's kind of funky. It's a little different there. And Nevada, same thing. Those are ones that you cannot typically use the HHW facility for VSQG disposal. But again, I would encourage you to reach out to those facilities and find out if that's an option for you. It has the potential to save you a lot of money in disposal costs. I get a lot of questions about, well, can I just neutralize it or precipitate it? Or especially from my science teachers, I will tell you a lot of those strategies can be referred to as treatment of hazardous waste. And in most states, generators are not allowed to treat hazardous waste to avoid generation of hazardous waste. You need to know the specifics for your state, and that's a really tough, that's kind of like the next level of hazardous waste management. So I just want you to know you need to understand that. When we're determining that something is a waste and we're trying to figure out, is it hazardous or not? The first thing, and the next couple of slides on hazardous waste determination, these are complicated. And these are things that once you decide your approach, either a big clean out and then sustainable practices, or a small 220 pounds at a time clean out, the hazardous waste company that you choose will help you identify these waste codes. Okay? You do not have to know this inside and out, but I do need you to have an understanding. So in order to define something as a hazardous waste, EPA has 5 different categories of hazardous waste. They have what's called, and each of these is established with a waste code, and it starts with a letter. So we call it the F list. All of those waste codes under the F list start with F, and they usually go like F002 or F005. Same thing with the K list, same thing with the U list. It starts with the letter, and then there's a 3-number sequence after it. All of these codes are available if you search on the internet for hazardous waste codes. Simply put that in there. You can put your state in, and it will tell you what the hazardous waste codes are. This is not something you need to memorize or know, in depth. I just need you to understand this at a pretty high level. EPA identifies waste 5 different categories. The first, the F list, is typically solvent blends. So things like parts washers, things like in your bus barn, if you have a parts washer, in the automotive shop, if you have a parts washer, that solvent frequently will fall under the F list. Sometimes we can buy solvents that are non-hazardous. That would be an excellent strategy to minimize your hazardous waste stream. K list is industrial waste. We don't have to worry about that in school. The next 2 categories, the U list and the P list. The way that I remember these is that these are unused and pure chemicals. These are most often found in our science departments, and these are what we consider in science reagent chemicals. So acids, solvents, bases, toxics, all of those that are hazardous are listed by name on either a P list or a U list. And again, you can Google that or search for that on the internet, and it will tell you what's the hazardous waste U list. If there's a chemical that's present on there, then if you go to dispose of that chemical, it is a hazardous waste. And then finally, the D list. The D list is what we consider characteristic hazardous waste. Basically, EPA kind of stepped back and said, okay, we can't list every flammable solvent everywhere, and there's constantly new ones being created. So we're going to say a chemical, if it has the characteristic of ignitability, I'm going to use flammability as an interchangeable, but really what EPA refers to as is ignitability. If it has a flash point of less than 140 degrees, it's considered flammable. And if it's flammable, it's characteristically hazardous. So we have to manage it as hazardous waste. All right. F list, U list, P list examples. On the F list, we also see solvent blends, things like in the art department, if we're using a bunch of different paint thinner, brush cleaners, and we collect them all in one container, that solvent is probably going to fall on the F list. Examples of U list, methanol, ethyl acetate, acetonitrile, toluene, a lot of others. A lot of legacy chemicals will be listed on the U list. And then we have the P list, and this is the toughest one. And this is the one that gives me a lot of headaches. We do see where we have legacy chemicals, we frequently find P listed chemicals. P listed are acutely toxic under EPA, and you need to know if you have these. Typically, what we see are cyanide derivatives, aluminum phosphide, nicotine, and that gets really complicated. We'll talk about it in a slide here coming up. Those are P listeds. I want you to put a little asterisk by the P list because there are some really tough things from a regulation perspective that we have to know about the P list. All right, ignitability, defined as anything with a flash point of 140 degrees or lower. Where do we find that? On the safety data sheet. Where do we see these? We see these sometimes in bus barns. We see these sometimes in automotive shops. We see them in labs. We do see them in art classrooms because of those solvents. Sometimes we see them in theater shops because of solvents. Lots of places with ignitability hazard characteristic. Next class of characteristic are the D002 corrosives. So it'd be acids, concentrated bases, and it gives us a pH range. So it's not even necessarily the concentrates. Some of our solutions may fall under this. There are some additional definitions other than just pH. For example, the solids, if they corrode metal, it's likely they are a D002 corrosive hazardous waste. Category 3 are the reactives, D003 reactives. These are usually the cyanides or the sulfides that can generate toxic gases that are coming off of them. There are also things that can become unstable, reactive, pyrophoric, self-flammable. Those are the different types of things that are going to fall under that reactives category. Examples of ignitable, paint thinners, parts washers. Examples of corrosive waste, potassium hydroxide, sodium hydroxide, and then of course all the acids, nitric, hydrochloric, sulfuric. Examples of reactives, D003s, calcium carbide, sulfide compounds, cyanide compounds. Examples of toxics, this is kind of a crazy one, but this is where the heavy metals or the toxic metals are identified. Under EPA's regulations, anything that meets a certain contamination level, that gets complicated. But if you are dealing with compounds in science, they are probably going to fall under this toxics category. Arsenic, barium, cadmium, chromium, lead, mercury, selenium, and silver are the EPA defined toxic metals that we need to pay attention to. Pesticides fall under this. So for example, if we're using like a 2,4-D weed and feed at the facilities level, that's going to fall under this. Frequently, these are ongoing hazardous waste streams. So these are also things you need to consider as you're building sustainability. Some of this stuff can get really confusing. There are chemicals that you are going to come across that you will look at and go, you know what, that's hazardous. It can hurt people or the environment. I better handle it as hazardous waste. And it may not meet the EPA definition. And some of these don't make sense. What I'm going to encourage you to do is if you find anything that you believe is a hazard to human health or the environment, that you set it aside, and even if it doesn't meet the EPA definition of a hazardous waste, please don't just throw it in the trash or dump it down the drain. Primary example, Glyphosate or Roundup in the United States is not considered a hazardous waste. We're pouring millions and millions of gallons on it in the Midwest. It's not considered a hazardous waste. But anything that has 2,4-D in it, typically a weed and feed that you can buy at a local box store, that's going to be a hazardous waste. Okay, this is one of those rules that doesn't make any sense. State codes, state rules may apply, and there are other chemicals that may be included under state regulation that are not included under federal regulation. One primary example would be used motor oil. A lot of states regulate that as hazardous. The federal level, it's not. Used antifreeze that's recycled. A lot of states regulate that at the federal government. It's at the federal EPA level, it is not. All of these things, your hazardous waste generator can help you, but really what you need to do is operate on kind of the rule of thumb that, you know what, if it's has the potential to hurt people or the environment, I'm going to consider it hazardous and I'm going to put it in the area where the hazardous waste company is going to dispose of those things. Now, as we talked about previously, the amount of hazardous waste that you generate in a calendar month determines the regulations that you fall under. The lowest number of regulations are applied to what are called very small quantity generators. And congratulations to all of you in New Hampshire. New Hampshire in 2026 now recognizes the same hazardous waste generator classifications that the EPA does. There are 3 categories. If you generate between under 220 pounds in a calendar month, you're a very small quantity generator. You're regulated at the lowest level, and you have the potential option to dispose of things at a household hazardous waste facility if your state allows that. The middle category, if you generate between 220 and 2,200 pounds in a calendar month, for example, you do a big clean out, then you move into that second category. And one of the ramifications is you only have 180 days to get rid of that hazardous waste. So you've moved up to a small quantity generator status. You have 180 days to get rid of that hazardous waste that you've identified. The third category is the large quantity generator category. This is where a lot of the largest industries in our country operate. They have the most regulatory requirements that they fall under. And these are generators that generate more than 2,200 pounds of hazardous waste in a calendar month. VSQGs have about, and this is rule of thumb, 15 regulations they have to meet roughly around storage and compatibility and labeling and container enclosure. Small quantity generators have about 50 rules they have to follow. Large quantity generators, we jump up to about 150. So as you can see, the regulatory burden increases, the timeline for storage decreases. If you become a large quantity generator, you have more than 2,200 pounds generated in 1 month, you have 90 days to dispose of your hazardous waste. 90 days. Okay, that can be a really tough timeline to meet if you're a school. Now, one of the challenges is if you have more than 2.2 pounds of P-listed acutely toxic waste, more than 2.2 pounds of that, you automatically go up to that large quantity generator status. And if that is the case with your district, the smartest option for you is to just do a one-time large cleanup and get rid of it all at once. It's expensive. You have to work within that 90-day time frame. But it's really the best option for you because you're operating as a large quantity generator. There are probably a lot of rules and regulations that you've never even heard of. And once you get rid of those P-listed chemicals, we very rarely see them on site ever again. It's usually a result of that legacy chemical buildup that's taken place over decades. So if you find acutely toxic chemicals, and to find those, what you need to do is internet search, what are the P listed hazardous waste chemicals? And it will give you a list. If you can go through your inventory of excess chemicals and identify any of those, you most likely need to do a large scale cleanup, do a one-time cleanup, get it all gone, and then build sustainable practices in. Examples of P-listed chemicals that we commonly see: cyanides and cyanide salts, arsenic trioxide sometimes, sodium azide. All of those are P-listed. There's a whole list of them. I'd encourage you to take a look at that. One of the other P-listed thorn in our side chemicals that we see on site at schools are vapes. If your school is collecting vapes that contain nicotine residue, even if they're empty, all of those little vape containers are considered P-listed acutely toxic waste. And yeah, you heard that right. Even if they're empty, they have to be considered P-listed acutely toxic waste. It's a really, really tough thing to try to figure out what to do with these. We have a webinar dedicated to vapes and PCBs coming up. Okay. So if you are collecting vapes currently, I would encourage you want to talk with one of us, and you might want to rethink that. If you're creating ongoing P-listed acute toxic waste, you'll be regulated at the highest category. EPA regulates if you have more than 2.2 pounds on site. Now, once you have your list of excess chemicals and you start making your hazardous waste determination, what you want to do is work with various hazardous waste disposal companies, and you want to obtain some bids. I would encourage you to at least shop it to 2 or 3 different hazardous waste companies. You will be astounded at the number of the differences in costing over those. Pricing for hazardous waste vendors, hazardous waste disposal companies is typically by waste code, by the quantity that you have and the size of the package that they have, or the size of the container they have to ship it in, and then the disposal methodologies that they have to use. Most waste at schools, when a company comes in to conduct a large scale cleanup, they'll develop what are called lab packs. So they'll take a bunch of small containers that are compatible chemicals, and they'll put them in one large container. That will save you money. So we want to see lab packs. You need to understand that the generator, you are responsible for making sure that the documentation from the hazardous waste company is correct. You want to make sure that the hazardous waste company they're going to create descriptions and shipping names. You'll want to work closely with them to make sure that those profiles, is the way that they refer to those, that those profiles accurately represent what waste is going into those containers. They will likely prepare the documentation and the labels. They will prepare all of that for you. However, you've got to find a company that you really rely on, that knows what they're doing and that operates in compliance, because if they mess up, you are still the one responsible. The generator is ultimately the one responsible from cradle to grave for the proper management of those chemicals, of that chemical waste. So you want to pick a hazardous waste company that is compliant, that is experienced, and that is knowledgeable, particularly in school chemical waste cleanups. The bidding process is complex. Ultimately, there are some things that you want to ask them. You want to ask for a price list of hazard class and container size with the correct DOT description. Ask them to put that together for you. You want to find out what they're charging you for a chemistry and for what they will charge you for personal protective equipment. You want to ask them, and this is a crazy one, but I have schools do this and save themselves several $100s. We usually overpack lab packs with vermiculite. You can go to your local box store and buy a 3 cubic yard giant bag of vermiculite for about $40. Most of the hazardous waste companies will charge you 90 bucks and beyond, so they double or triple the price. Ask if you can provide your own vermiculite. It'll be a good cost savings for you. They're going to also charge things like mileage rates, demurrage, cost to get the truck to you, fuel surcharges. There's a lot of DOT shipping costs associated with those. If you can use an HHW facility, a household hazardous waste facility, and drive the waste in yourself, which I know sounds terrifying, but there are ways to do it safely, you can save yourself a significant amount of money by driving in 220 pounds at a time. And we have DOT exclusions, so you don't have to have all of the placarding and all of the requirements to meet DOT. We have to do it safely, but there are ways to do that. There are also minimum charges for what a hazardous waste company will refer to as what's called a pack-a-loan, or a specialty, very dangerous chemical. Those are chemicals that have to be packed individually in containers and shipped. Overall, what you want to do is present them with an inventory of the chemicals that you want disposed of and ask them for a whole quote on everything. And then make sure you're evaluating their competency and their level of knowledge. Hazardous waste is shipped on a particular document that is required by EPA. It's called a manifest. DOT and EPA both regulate the manifest, and there are a lot of details in filling it out. In order for you as the generator to sign that DOT and EPA manifest, you have to have a minimum of DOT training. So please do not just sign the manifest or assign somebody else in your office to sign the manifest without having that DOT training in place. There are a number of entities across the internet that offer that as an online training course. Please make sure you have that in place. The hazardous waste company will assign waste codes. So we talked about the F codes and the D codes and the P codes and the U codes. The hazardous waste company will assign that based on what they're putting in those lab packs. You need to at least have a little bit of familiarity with those waste codes to make sure they're correct. Again, when you sign this, you accept responsibility for the manifest and for all of the hazardous waste. Make sure you at least have a general idea about those waste codes. Generator has to have some understanding of waste codes, shipping names, and what's required on that manifest. Once you sign that, once you get the DOT training and you sign the manifest, you will receive what's called, you will receive a front copy of the manifest. You will also receive the last copy of the manifest when it reaches the treatment storage disposal facility for final disposal. You want to keep both of those copies. You will also receive documentation on land disposal restrictions. You want to keep all of that documentation. I would encourage you to scan it and digitize it, but also keep the hard copies. Those should be kept at the district level or at the site level, as long as there are multiple people that know where those are. If there's ever an incident or an inspection, you will be asked to produce 3 years of those documents to be able to demonstrate that you know what you're doing when it comes to hazardous waste management. Other areas that are going to continuously generate hazardous waste that you really need to get a grasp on and that you need to build as part of your sustainability of your hazardous waste disposal program: labs, of course, art departments, theaters, greenhouses, career and technical education, bus barns. Additional hazardous waste streams, additional waste streams. There's a unique category of waste that's called universal waste. These are wastes that are commonly found all over the place, and if we didn't manage them through recycling, it would put every generator into that large quantity generator status, most likely, because everybody has these. These are called universal waste categories. Universal waste categories include things like rechargeable batteries, particularly lithium batteries, lamps or fluorescent light bulbs. EPA refers to light bulbs as lamps. It's another part of that language difference. Lamps, mercury-containing devices, and some states consider aerosol cans as universal waste. Some states consider used oil as universal waste. So know what your state identifies as universal waste and include that as part of that management, that overall hazardous waste management procedure, so that you've got sustainability in managing those as well. Coolants such as antifreeze may be also regulated as hazardous or as universal waste. Sometimes pharmaceuticals, like from the nurse's office, are managed as a special category of pharmaceutical waste. That gets very, very complicated. It's very complicated. These also vary by state. Your hazardous waste company that you select or your household hazardous waste collection facility should be able to help you and guide you on what ongoing wastes you may manage. Hazardous waste has to be stored correctly. So once you identify something and you move it from that excess chemical into the hazardous waste category, it needs to move unless you're doing a large scale legacy chemical clean out, and then you can leave everything in place and just do that one-time large clean out. There's no sense in moving all of those old containers. It's very dangerous. So leave them in place, let the hazardous waste company go to them and pack them. Once you identify that sustainable, those ongoing waste streams, though, there are two different storage areas that you need to take into consideration. One is called the central accumulation area. This is where we stage all of the hazardous waste immediately before it's either taken to an HHW facility or a hazardous waste disposal picks it up. The other are those small containers that operate throughout your site, where we dump little bits of hazardous waste maybe every day into. Those are called satellite accumulation containers. And EPA and the states both have regulations that we have to follow for those ongoing storage of waste location areas. In a central accumulation area, so when we fill up one of our satellite accumulation containers, within 3 days, it needs to be moved to our central accumulation area. The central accumulation area has to be managed for all of the containers have to be labeled correctly. This is probably the biggest problem that I see. They have to be labeled with the words hazardous waste. They have to have either a DOT or a OSHA pictogram on them depicting the hazards associated with that chemical. And they have to have the date that they were put into that central accumulation area. The reason that we have to date those is, again, we have different storage allowances depending on our generator status. VSQGs can store for, I'm going to say 360 days as a best practice. Technically, under the federal code, VSQGs can store waste indefinitely. I'm going to tell you that's really not a good practice. At least once a year, clean out those central accumulation areas. Large quantity generators, so if you immediately find those P listeds that you need to get rid of, large quantity generators have 90 days. Small quantity generators, that category of 200 to 2,200 pounds of hazardous waste, have 180 days to dispose of hazardous waste. The way that we determine how long a hazardous waste container has been sitting around is that we put a date on it when it goes into that central accumulation area. So label, and it needs to include the words hazardous waste, a DOT or a hazard communication pictogram indicating the type of risk of the container and the date that the container was placed into the central accumulation area. And we also, a best practice would be to put a DOT shipping name or a description of contents onto that label as well. It's not required. The DOT and the HAZCOM labels identify the level of risk, but really do your chemical hygiene officer a favor and put a description on there as well. Central accumulation area rules include that everything has to be labeled. Everything has to be in containers that are in good condition with no leaks. If we do have a leaking container, it needs to be containerized in secondary containment. All of the containers have to be closed unless we're adding or removing waste. They have to be compatible with the chemical that's in them, and they also have to be stored by compatibility. So we don't want acids and bases stored right next to each other. We need to have space between them. There may be additional rules at the state level, but the container or the central accumulation area needs to be set up by site so that you can manage the hazardous waste that you're generating on an ongoing basis. This is an example of what a satellite collection container looks like. This is what's used frequently in university labs. Now, I will tell you, one of the things I look at when I'm talking to schools, and I'm going to run out of time here, and I apologize. I'm going to go as quickly as I can, but this is important stuff. The satellite accumulation containers, you should not just have one for your lab. You need to have one for each type of waste. So one for acid waste, one for base waste, one for solvent, compatible solvent waste. So whenever I walk into a high school and I see either no hazardous waste containers, but I see that they're using solvents, I know they're not doing it right. Please make sure that you understand that you're going to need to collect those small amounts of hazardous waste on an ongoing basis. That satellite accumulation container needs to have the words hazardous waste on it, and it needs to have a description of what's in that container. It does not need to have a date. It's not full. Once it's full, we put a date on it. It moves to the central accumulation area. It always has to be closed. It has to have that label on it. And again, we can't accumulate it. We can't let it sit there for more than 3 days. We also cannot accumulate more than 55 gallons at a time in a satellite accumulation area. So small containers, we fill them up, make sure they're labeled properly and they're closed unless we're adding waste to them. Then when they're full, we move them to the central accumulation area. We put a date on them and we sort them by compatibility, and we make sure that they're closed and not leaking. We have to have a system-wide approach if we're going to aim to stay below that 220 pounds per month. And we need to make sure we're evaluating chemicals to see if we really need to use hazardous chemicals or if there's a different option. We want to minimize our hazardous chemical usage as much as possible to try to stay under that 220 pounds a month, so we fall under the least number of regulations. And we want to make sure that we're establishing those long-term collection strategies. We have just gone through all 12 steps. I know it was a whirlwind. I know your brains are probably exploding a little bit. So if you have any questions, please send them in the chat, or you will have my email at the end, and you'll also have my phone number at the end of the presentation. Biggest things to remember, this is complex stuff. This has been a career endeavor to try to understand all of these regulations. And every time I dig into them, I find a little bit something new that I didn't know before. You have resources to help you with this. You have 30 minutes of time with my company or me, if you'd like. You also have resources that are available through the Lab Safety Institute. A lot of universities have exceptional resources on their websites, and hazardous waste companies can help you as well. Now, to finish off, we're going to go back to that demonstration of competency. So true or false, flammable solvents can be dumped down the drain if you flush them with lots of water. No, they are hazardous waste and they have to be managed as such. That's false. Art departments don't have hazardous chemicals that are regulated. That's also false. Art departments usually have things like ceramic glazes, they have paints, they have paint thinners, aerosol cans. A lot of those types of things show up in art departments, and they are regulated as hazardous waste. Third one, school districts are exempt from hazardous waste regulations because they're government entities or government facilities. That's also false. You face as much regulation as our chemical companies do. So it's important for you to minimize your risk, minimize your chemicals as much as possible so that we don't have to meet those super high numbers of regulatory requirements. Steps to take today: continue to work on developing that chemical inventory of excess chemicals. Continue to evaluate. Is there someplace else that can use them in the district? If not, figure out your strategy. Make sure that whoever is going to be signing manifests has DOT training. That's a big miss I see in a lot of school districts. Have to have that DOT training. Begin to identify hazardous waste companies that you can work with. Above all, as you build out that inventory of excess chemicals, please be very safe. Again, moving those really old, especially science lab chemicals around can be dangerous. And then we have a webinar next week on how you evaluate the risk of chemicals using the safety data sheet and some other resources to determine, is this something that you really want, or can you move towards smaller scale, green chemistry techniques? Are there different choices you can make? All right, here is my email information. Here's my phone number. You also have information that you can reach out to the Lab Safety Institute, your hazardous waste disposal companies, and the Upper Valley Lake Sunapee Regional Planning Commission also has a lot of resources on their website. I know we covered a lot today. Thank you so much for hanging with me. I know it was a lot, so if you have any questions or you just need some encouragement that you can do this, reach out. We're happy to help you. Thanks for your time.